Hi all, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's problem. Our problem name is delete middle of the linked list, right? Let's read the question first. Our question said we are given a singly linked list. We have to delete the middle of the linked list. For example, we are given a 1, 2, 3, 4, 5. Then the linked list should be modified to this 1, 2, 4, 5, right? 3 will be the middle. So we have to delete that middle element, right? Now, if there are even nodes, right? In the previous example, we have odd numbers, right? If we have even, then there would be two middle nodes, right? We have to delete the second middle of it, right? So if you see here, 1, 2, 3, 4, 5, 6, we have even numbers. So it should be modified to this 1, 2, 3, 5, 6. Now let's understand this question better. So let me take these two examples. So in the first example, we have odd numbers, right? So in the odd, we see here we have two nodes, here we have two nodes. It means this is the middle, right? Okay. Now this is even number of nodes, right? If you see here, in the left we have two nodes, in the right we have two nodes. It means that these two are the middles. But in the question said, we have to delete the second middle of it. What's the second middle? This. So it should look like this. 2, 4, 6, 5, 1, right? Because this is the second middle. This is the first middle, right? So in this case, our answer is after deleting the middle, it should look like this, right? Okay. Hope you understand till now. Now, how we can solve this question? So let's take these two examples, similar examples. Now, I want the middle element, right? How we can solve this? So simply we can solve using tortoise method. In the tortoise method, what we are doing is we use the two pointer approach where the slow moving one step and fast moving two step, right? At the same time. Okay, so let's do this. So initially both slow is pointing to first node, which is head, fast is also pointing to the first node. Okay, so in this case, what I'm doing is slow moving one step. Now slow is pointing to this. Let me raise this, and fast two step, one step, two step. Now fast reaches to this node. Okay, again slow moving one step. Now slow is here, fast moving two step. So now fast is this. If you see clearly, let me raise this first, which we are deleting already. If you see this, just see this thing. Your answer, your middle element is 3. It means that we already reach to the middle element, right? Where the slow is pointing to the middle element. So what will be your stopping condition for the fast? Simple. If my fast car next equal to null, it means that slow is pointing to the middle element, right? We have to stop here. Okay. Now let's see in the even number of nodes. Now initially slow is here, fast is here. In the first step, slow reaches one step ahead and fast reaches two step, means 1, 2. Fast is here. Again, slow go to one step ahead and fast go to two step ahead, means one step, two step. Now fast is pointing to this. If you see again, slow pointing one step, fast moving two step. Now the fast is reached to null, right? If you see clearly, I want this should be my middle and slow is pointing to this node, right? We have to stop here. What we have to write in the even case, when my fast equal to null, we have to stop, right? So to delete the middle element, where we have to stop, these two condition is fulfilling our need. Okay, in these two conditions, my slow is pointing to the middle element. Okay, now how we can solve this question? After that, if you see here, let me raise this because I only want slow, right? Now what I'm doing here is just see clearly. I want to delete this. I want to delete this. Okay. To delete this, what I'm doing is I just want previous of slow, right? Suppose previous is a pointer which is pointing to just previous of slow. Let me write here previous. Now what I'm doing is simple. Previous ka next equal to slow ka next. And this should be out of my linked list, right? If you see here, this is my previous and I'm just doing is previous ka next is linked to slow ka next. What I'm doing here, previous ka next equal to slow ka next. Simple. At the end of it, what I'm doing is I just return the head of, which is the head of my linked list. Simple. Okay, so let's do the coding part of it. So here the condition is also given. If we have a single node, we have to return null in this case, right? Okay, so let me write here if head connects equal to null, it means we have single node. In this case, we have to return null. As I said, we need two pointers. So the first is slow, which is pointing to the head of it, and fast equal to head, right? Now I want just previous of slow. So let me create another pointer which is previous. Initially it is pointing to null. Okay. So the two condition where we have to stop our while loop is first is when fast not equal to null and fast connects not equal to null. Until this condition we can run, right? What I'm doing is first condition is we have to update my previous while going slow one step ahead, right? Because I want just previous of slow. So that's why what I'm doing here is previous equal to slow. Okay. Now slow is going to one step ahead and fast two steps, right? So here fast is fast ka next ka next. Okay. Now, when this while loop is finished, we know that my slow is pointing to the middle of it and the previous is just previous of slow. I want previous connects is slow connects. So simply we have to write here previous connects equal to slow connects, right? At the end of it, simply I just return my head of it. Okay, simple. Let's check it's working fine or not. Yeah, the compilation is good. Let's submit and check. Yeah, as you see, all the cases are passed. Okay, so what will be the time complexity of this solution? Simple. We are just traversing our linked list which having n nodes, right? So our time complexity of the solution is big of n, and we are not using any extra space. So what my space is, it's constant, right? Big of 1. Okay. Hope you understand this question and solution. Thank you so much.